Did dinosaurs shit liquids? And many other important questions. I'm going to be talking about questions today. Questions that people have asked me in my Discord server, and questions that I'm going to be answering to the best of my ability. These aren't all paleontology related. Some of them are more science based. Like I think there's one about radiation, and I skimmed over some of them. I'm not really sure. So this one's by Vegeta the Explainer. Is Pachycephalosaurus completely herbivore or not? So he's obviously asking Pachycephalosaurus, which is a herbivorous, or at least we assume it's herbivorous, a dinosaur that lived in North America during the Maastrichtian stage of the Late Cretaceous period. To answer your question, I don't know. You can't be completely certain of an animal's diet until we have remains of its diet. If you would ask me, I'd say that it's probably designed for a more omnivorous diet. In fact, most herbivores in the modern day aren't completely herbivorous. They're just titled herbivores because they mostly feed on plants. It doesn't mean they always feed on plants. So I would say that's probably an insectivore mixed with herbivore, a little bit of both. But yeah, that's a really good question. I think we'd have to find more evidence to really answer that properly, and it's a very interesting sort of topic. This one's by Sinosauropteryx prima, which is a gorgeous animal, by the way. Why is radiation poisoning a thing? Radiation poisoning happens when your body takes in too much radiation, or it's too much harmful radiation. So take Chernobyl for instance. The Chernobyl incident, which occurred in 1984, I want to say, I'm not sure, was basically a nuclear meltdown because they weren't the cooling systems in the nuclear plant in the town of Chernobyl in Ukraine failed, and the nuclear reactor overheated and exploded, and there was radiation emitted everywhere all over the city, and everyone had to leave, and people got cancers and tumors, and people in the nearby vicinity died like instantly. It was horrible. It's the worst non-deliberate act of nuclear. Actually, I think it's like the second worst non-deliberate nuclear act ever seen in human history. I think the Japanese nuclear meltdown was probably the worst one. So, radiation poisoning. So in this instance, people got too much radiation. If your body can only, all right, think of your body like a greenhouse effect sort of biosphere. You can take in certain contents of things, small amounts of things, but as long as you're letting all the massive amounts out, or you're not taking in those massive amounts, you'll be fine, or relatively okay. But if you take in too much radiation and you can't get rid of that radiation, you're going to suffer because your cells are going to mutate, you're going to get diseases and tumors and cancers and all sorts of crazy things because it's genetically changing your DNA. And your chromosomes, and it's doing all sorts of things to you. It's awful. Don't get radiation poisoning. It's like skin cancers, for example, melanomas. They impact your skin, change your whole genetic makeup, so this cancer is now spreading and attacking your blood cells and spreading throughout your body. It's a growth. It sucks. This one's by Lara. If we're going so fast through space, why does it look like we're going slow? Because space is big. Next question. Yeah, space is really big. If I put an ant in this box, and the ant traveled from this end to this end, it would look like the ant's going really fast, because it's a small area. But if I put that ant in space, going at the same speed, it would take it ages to get from one side to the other, because it's a massive amount of distance, and the ant's going the same speed. In fact, even if I made the ant go 4 million times faster than it would in this box. Why is it? Hang on a second, give me 1 second. Hopefully that's a bit better. I realized the lighting was just really bad. I was using natural lighting mostly, but kind of sucks. Another big factor is distance. If you take, I don't have planets to like do this with. Okay, this is the sun. This is a goniatite. It's a fossil. This is the sun, and this is Earth. Okay, Earth's like over here, right? Sun's like right here. Earth has to rotate around the sun. The sun is enormous, much bigger than the Earth, and there's a massive distance between the sun and the Earth. It doesn't matter how fast the Earth's going, it's going to take it ages to get around the sun and that enormous distance from the Earth to the sun. That's what an orbit is. Is there any way we can see or visit prehistoric life? This one's by Lara as well. Yeah, they're called coelacanths. They're fish that survived the KT extinction and lived on all throughout the Tertiary and Quaternary into modern day. But if you're talking about extinct animals, there is a way that you can see them, but it is impossible. If you were to travel, okay, 66 million light years away from the Earth, out into deep space, you would see the asteroid impact that wiped out the dinosaurs. You would watch it happen, because the light from that event is only just reaching your position in space. The problem is, we can't do that. We can't travel at light speed or faster than light speed, because kinetic energy that it requires to go at that speed would fall apart and break space-time. No object should physically be able to reach light speed. It is impossible. So, good luck with that. But that's what CGI is for, right? I mean, every year we encounter new paleontological discoveries that show us important things that we never thought about prehistoric animals. Feathers on large theropod dinosaurs and the tyrannosaurs, they're only really recently starting to show up in Eutyrannus, for example. That came out, we discovered that a few years ago. So effectively, it may be best to just wait it out. Wait 20 years until we really have definitive knowledge of these prehistoric animals, and we can really give you some insightful information about them and produce a physical reconstruction of them to the point where it's almost lifelike. Because right now, we're working on that. And we've got it down pat, to be honest. I mean, we know what generally most dinosaurs probably look like, but there are some things we can't really be sure. Coloration, percentage of feathers on the animal's body. If they had large keratin structures emerging from the horns that we find in Albertosaurine dinosaurs. But yeah, this is basically just wait it out, Lara. Be patient. There's a link to my Discord server in the description. Don't forget to like and subscribe, and I'll see you guys next time.